Hi, and welcome back to this, episode 32 of my seemingly unending series of getting this machine modified and CNC'd and up and working. Long-time viewers will know that this channel's #1 fan, Nico, and I are both big fans of Bad Obsession Motorsports' Project Blinky. Though there's not much happening there lately. Honey, I think Nico's a bit upset about Project Blinky.
Okay, now this is ridiculous. You can't post a 44-minute on the 20th of June and then nothing for months. And then 4 videos of a new project in 2 weeks. This is bad content management, sad emoji. Bad for the mood of the viewers. The last thing you want is a pissed, frustrated viewer. You want an impatient viewer. I guess it's like with a wife. Wonder what that's supposed to mean. How is coming your new episode along? Cheers, Nico.
This episode, unfortunately, starts with disassembly. I made a couple of pretty big screw-ups and I need to fix them. One of them is this motor. For some unknown reason, I didn't look at the data plate of the motor before I started designing the belt reduction. I assumed this was a 4-pole motor with a speed of around, 1400 RPM. Well, it's not. It's a 2-pole motor, which means it runs at about 2800 RPM here on our 50 Hz power. And with the belt and the reduction gears in high speed, I end up with a maximum speed of about 6000 RPM, which is basically way too fast for the bearings I put in. So what I've done, I bit the bullet and bought a new motor. Same frame, it's once again just a normal 3-phase motor, but this time it's a 4-pole motor, so it'll turn at the 1400 RPM. I'm of course running it on a VFD with a maximum frequency of 100, so that'll double that speed to 2800, which should give me my 3000 RPM in high speed and roughly 1200 in my low speed. I'm hoping this is just a one-to-one swap, but who knows? I mean, things like this housing's wider, so I hope I don't get into interference issues around here. The new motor's got a 19mm shaft. I got a feeling the old one's 14mm, so I might have to make a new pulley. I kind of thought that those were the same frame size, but they're not. I think this is B80 and this one must be a B90 or B100 or something. Thinking back, I'm pretty sure I looked at this once before, where you can't get the 2-pole motor in this frame size, which of course is a problem because now nothing's the same. Yeah, you can see that from here, that's 14mm, that's 19. So I guess I've got a bit of work to do getting this motor to fit. You know, there's a saying in the home-built aircraft community that change one thing, change everything. And I'm sort of starting to get that feeling. The whole pattern of the feet is completely different. I'm kind of wondering whether I can just switch the feet over. Well, that's not going to work either. Yeah, this is probably going to be difficult as well. I don't really know if I can put any more holes in this. This terminal block is kind of huge. The one off the grey motor is substantially smaller, so I think I'll switch them over. Pretty sure they've got the same mounting footprint. Seems to be about 52mm square. Okay, well that was a fail. It's not the same size. This one is much smaller on the bolt pattern. Oh well, it was worth a try. Started looking at an adapter plate between this bolt pattern and the existing one when I realized, you know, those feet themselves are really only an adapter. So why don't I make just a single adapter, use it and just pick up those 4 holes onto a plate out to here. I'll need a couple of 10mm spacers to bring this up, but then I could just make a single plate and bolt that on and get rid of these feet which just take up way too much space. These are tight. I think I rescued this set of 4 screws from a bicycle's brake pads. They look like kind of nice screws, so I didn't throw them out when the pads wore out. So I'm just mocking this up here. It looks like it's going to fit, but I've got a little bit of clearance down in here between the drive motor and the mounting plate for the encoder, and it looks like the belt should line up nicely. So I've just cleaned up the edges of this a bit with a file. Now I'm going to sand down those 2 pads, take the aluminium oxide layer off, and then JB weld the parts together. Since aluminium's oxide layer reforms basically immediately with contact with air, I believe the proper way to bond aluminium, if you want the really strongest bond, is to put a layer of epoxy down, use quite a rough grade of sandpaper, and sand the epoxy into the surface to keep the oxygen away. But that'd be kind of overkill for this because there's going to be bolts clamping this together anyway.
Day 2.
Okay, well that looks like it's going to work. Pretty sure I've got clearance everywhere. So next up I need to make a new pulley. I'm pretty sure this is the 20-degree flank angle or 40-degree included angle bit I ground up for making Polyv pulleys. For these PJ style multi-rib pulleys, you've got this is like a 40-degree included angle. You need to go in 2.06 millimeters is nominal, and the ribs are spaced 2.34 apart. So I'll set up a clock for this dimension and just use the cross slides scale for the depth dimension. That's 1 millimeter on diameter. I need to go in a total of 4.12. Unfortunately, I'm getting a lot of chatter. Well, it definitely cut a lot better once I increased my feed. Kept a constant cutting feed on it, didn't chatter anywhere near as much. So let's do that again. So like this, it cuts very nicely. Try doing that in Mini-lathe. I'll put in a center and support this when I'm cutting the grooves so it doesn't chatter. Now the norm for the pulleys, of course, has a rounded crown on each of those pieces, so I'll just do that with the file. Now that I've got all the external features finished, I'll drill and then bore this for the 19mm shaft, hopefully to get everything nice and concentric, turn it all in one setup, and then I'll part it off. When I bought my lathe, there was a bunch of sort of random stuff that came with it, including all these ring gauges. So since I need to check a 19mm bore, I've got a 19mm ring gauge, so I'll just give that a quick clean up, take any rust off it, and use that to set bore micrometer to measure it out. Okay, so it looks like I've gone probably 2 to 3 1/100ths over on the bore. That's a little bit looser than I would have liked, but yeah. Now just turning it around to face it off. Let's put a bit of beer can in there to try and cut down on the damage to the surface finish. So next up, I'm going to need to put a keyway in this, aren't I? Luckily this keyway cutter is already ground to the right width. The only question is whether this tool holder is going to fit through my 19mm hole. Yeah, no, it's not. That's too long. I guess the other option is just use the small one and cut the key in 2 passes. I think I'll do that. To line up the drive lugs, I'll just set the gearbox in neutral. Okay, so I've now put it on center. This is only a 3mm wide tool. I need a 6mm wide key slot. So I'll be offsetting it 3mm minus, 3mm plus. Oh man. You know, I would like to make one episode without screwing up, but this is 3mm wide. I need a 6mm slot. I offset it to -3, thinking I'd then go to +3. But of course that would then end up with a 9mm wide slot. I should have offset it to -1.5, +1.5. I guess the cleanest way to fix this is just rotate the pulley to bring this back roughly onto the center line and then cut both sides. Well, let's try this out. Okay, it's maybe a little bit loose, but once it's secure it with a hubcap on the end, I'm sure it'll work fine. A little surprise, I've just found out that this hole is not threaded, so I can't just thread a hubcap into it. I guess the easiest way to secure it's just going to be put a set screw down there to run onto the key, or drill and tap the shaft. Either way, I think that's going to be a job for another day. I'm going to finish this video here and see you again next time. And as always, thanks very much for watching and a big welcome to all new subscribers. Thanks for joining.